So percent problems is what we're going to do today. Percent problems, this is how I want you to set them up. You may have done them differently in another class, and that's fine. This is how I want to set them up every time today as proportions. Because we've already done proportions, and you guys know how to do those. So the way that you want to approach a problem is when it's written in a question form like this. What percent of 25 is 17? The setup is always going to be is over of equals percent over 100. Is over of equals percent over 100. If you set them up like that every time, then there's not any question about where the x goes. Okay, so they say what percent of 25 is 17. So if we take that is over of, the part that's the is the 17, the of is the 25, and they want us to find what? Percent. So we're setting this equal to x over 100, and that's going to get us the percentage. And it's a proportion, so yeah, cross multiply, and then 25x equals 1700. One step, divide. $25 goes into 1700. In $17, there's 4 quarters in every dollar, so that's 1,700 cents. So that'd be 4 times 17 would be 68. So 68. So it'd be 68%. To answer the question, it would be 68% out of that. So x equals 68, and then the answer to the question is 68%. So is over of equals percent over 100. Example B. It is. They don't get much harder. What number is 30% of 90? Okay, so this one's ask a question related to percents. It's a little bit different because it says what number is, and then it gives you a percentage of 90. So if we take the is over of, the percent always goes over what? Over 100. If they give you a percent, you know that number's going over 100. So it's 30 over 100. The is, it says what number is. That what number is the x. Is over of. What's the of? 90. Abel, you have a question? No, we know the percent. It's 30. So whatever the percent is goes over 100. In the first example, we were looking for the percent, and that's why we put an X there, because we didn't know the percentage. If they give us a percent, we know that number goes over 100 every time. Always. That 100 is always going to be there. If they give us a percent, we put that number on top. If they don't give us the percent and they ask us to find it, then that's when we put an X there. Cross multiply, same story. 100x, 30 times 90, 2,700. Well, it's easy when they ask us to divide by 100 because the zeros cancel each other out, so that's 27. And to answer the question, what number is 30% of 90? Just the number 27. Don't put a percentage on it because it didn't ask for a percentage. It asked for a number. So be careful of that. Let's see. What percent of 136 is 51? So let's set it up. Is over of equals x over 100. Percent is what we're looking for here, so that's why the x is on the top of the 100. Percent over 100. Cross multiply. No, you could put the x over 100 on the left side and then the 51 over 36 on the other side. It doesn't matter that way. Yeah, that's a good question because it doesn't matter. I guess out of habit, I always put the x over 100 on the right side. I don't know why. Maybe that's the way I learned it, probably. That's probably why I still do it that way. 136x, 5100. Do that division. Be 37 and a half. And you can use a calculator on this quiz that we'll take tomorrow after lunch. It will be calculator, no non-calculator on this particular quiz. Because percent's usually a calculator or something we're going to use. So x equals 37.5, and the answer to the question, that's 37.5. Does it get a percent sign? Yes, because they're asking for a percent, so we got to have a percent on there. So some context to the problem is the key. Okay. Let's do one that's a little bit more difficult. What number is 150% of 50? It's a weird problem, so gotta throw that in there because it's asking for more than 100%. Should our answer be less than 50 or bigger than 50? Bigger. 150% is bigger, right? So it should be bigger than 50. So let's set it up. On the side, we put 100 on the bottom. Doesn't matter which side we do that with. What goes on top of that? 150, the percentage. What goes on the other side? X over 50, is over of. And then we cross multiply. 100x, 15 times 5, be 50 and 25, 7. 5, 2 zeros, 7,500. Divide by 100. That's easy. 75. Does that get a percent? No, it's just 75. Easy stuff, right? Let's go to another one that's a little bit different. Same kind of idea, though. Setup still similar. 65 is 62.5% of what number? So let's get the setup on this one. What should one side of it be? 65 over x. 62.5 over 100. Good job. Absolutely. 65 is, so that's the is over of what number? That's the x, or whatever letter you want to use. Cross multiply. 62.5x equals 6,500. Divide. Somebody that's got a calculator help us out there, just to save us a little time. It's 100 and something. 104 even. No, nothing after that. Awesome. 104. 104. No percent sign on that because we already had something else with a percent sign. All right. Easy stuff, right? Is over of equals percent over 100. All right, so percent problems are some of the most useful math things that you'll do in algebra for everyday life, because you're gonna encounter sales and things like that in life. You're gonna have to calculate how much tip to leave and all that stuff. And I know there's tip calculator apps for your phone and all that stuff, but you need to be able to do it without that, because somebody might kind of cheat you if you don't know what you're doing. So what letter are we on here? G. All right. A bill was $15.75, and you want to leave a 15% tip. What would your total be? Okay, so let's say you went to a restaurant, you ordered dinner, $15.75. They bring you the bill. You want to leave a tip for your waitress, waiter, and you want to leave 15% because it was good service, not bad service, not exceptional service. That's a pretty conservative tipping amount. 18% is considered good service tip. 20% if the numbers work nice is kind of what I try to do. 10% tip is minimal service. It's what etiquette is, but that's beside the point. All right, so what are we looking for here? A couple of different ways to work this, but what's one way to work it? Finding what? We're going to leave a tip. We got $15.75 what our bill is. We need 15% of that. Or at least we need to find 15% of that. So flip that other side. We need X over 1575 equals 15 over 100. If we want to find 15% and then add, which is, I guess, the typical way of doing that. And cross multiply, just like we've been doing. So that's 100x, 15 times 1575. Let's get a calculator out. Might have got that number. 236 and a quarter. And then divide by 100. All right, $2.36, a little more than 36 cents. This would be a personal choice whether to round up to 37 cents or round down to 36 cents. If we use the mathematical principle of rounding, we're going to round down to 36 cents. Right? So 15.75 plus 236. $18.11 would be our total. Now, normally I would try to make that round out to a nice even dollar amount. Give them more, 89 more cents and make it $19 is what I normally do. I'm paying the bill. But that's one way to do that. What would be another way to get that total bill without having to do the addition? Instead of putting 15 over 100, what could I put there? No. So that when I solve the proportion, not 1.5, but 115%. Because I'm paying 100% of the bill is $15.75. If I'm adding a 15% tip, it'd be 115%, right? So you could do that, and then the answer to your proportion is your total bill. So there's a couple of different ways to do that. This is the most common way for folks to do that, is to just find 15% and add it to it. That's what most people do. That's the way your receipts are printed out. If you pay with a card, they always have a line for your tip and then a total line. So they expect you to find the tip and then add. And that's actually, easier for the restaurant because they have to total up their tips. Some restaurants do tips differently than others. Some pool everybody's tips and then divide them evenly. Some of them, whatever you get is what you get. So it's different ways of doing that. So there's a tip. let's look at this scenario. Example H. This is the most common scenario with folks that if you pay with cash, your bill is $12.43. And say you got a drink and a corn dog at Sonic, and that's what your bill is. That's probably about right. And you pay with $15 cash. You tell, you say, waitress, to keep the change. Better way of asking that question. What was the percentage of your tip? Maybe it'll catch up in a second. Did this last block or first block this morning, and it caught up. All right, we'll try again. All right, so the bill is, and while it's trying to connect there, the bill is $12.43 is what the bill is. I'll go to this paper here. And you paid with $15. There it is. Let's back up. I threatened it with a marker. We want to know what percent of my tip was. Okay? Because I told them to just keep the change. How can I find that? So I'm looking for a percent. So obviously one side is that. What would the other side be? Would that get me the percent of my tip? That would get me the percent of the $15 that was my bill. It wouldn't get me the percent of my tip. My bill was $12.43, right? So a couple of different ways to work this. One way would be finding what the total percent was for $15. Should be something over 100%, right? And then we would take 100% away from that. That's one way to do that. I guess the more straightforward way where we get our answer right as soon as we finish our proportion would be take $15 minus $12.43 and get how much money did we leave as a tip, and do that subtraction there at the beginning and get there. I think that's the more straightforward way of getting the answer so that you only work one math problem and you get the answer. I think that's more straightforward. So what is $15 minus $12.43? Or $2.57. And then we have this proportion to work. And I really probably wouldn't expect you to write this problem, just write that problem down and then solve it. And that's going to get us our percentage. So 1243x equals 257. Do our division. And let's round to 2 decimal places on that. 2 decimal places to the hundredths position on that percentage. So 257 divided by 1243. So 675 would make that round to 0.6 what? 68. 20.68. So our tip is 20.68%. I hope the service is really good. And whatever you ordered tasted great. It's just $2.57. You gave them a $2.50 tip there. So that's being a good person, man. You're supposed to tip. All right. So let's look at. So we've done some tips. Let's look at shopping. Shirt is marked $19. It's supposed to be an I. Sorry, there you go. Yeah, it didn't look quite like an I, but it is now. I mean, it's more like an I than it was. And it's on sale for 20% off the marked price. What is the sale price? Well, here's something that you're doing. You're shopping. You got a shirt that's marked at $19. It's on sale for 20% off of that marked price. So we'll do it math class style, and we'll do it how you probably should do it in the store. Some of you that are shoppers probably already know how to do it in the store, like the quick way to get the number or get an estimate for what it costs. Yeah. And that would get us what? What's that going to get us? No. The discount amount that we've got. What could I change in this problem and actually get the sale price? The percentage. If it's 20% off, how much am I paying? Well, what percent am I paying if it's 20% off? 80%. I'm only paying 80%. So I could set this problem up as 80 over 100. And then when I find X, I actually get the sale price so that I get one answer here and I don't have to do that subtraction at the end. So it saves me a step to say, okay, it's 20% off. That means I'm paying 80%. So I find 80% of $19. 19 times 8 be 80 plus 72. The 30, let's just do 19 times 80. 15, 20. Divide that by 100. That's pretty easy to do. Just move the decimal place twice. $15.20 is my sale price. That's how much I'm paying. So my discount, if I'd have used 20 over 100 there on the right side, I would have found that the discount was $3.80. And I would have to subtract that from 90 or from 19 to get my sale price out of that. Now, if I'm in the store, I don't usually pull out my calculator and do the actual numbers. I look at it and say, okay, 20%. Well, what's 10% of $19? $10 would be, move the decimal one place, $1.90. Okay? And then 20% is how many 10%? 2. So $1.90 twice. Yeah. Right? That's how I do it in the store. If I'm walking around and I need to quickly just get an estimate, how much off am I going to get there? Well, it's close to $4 off because $1.90 is close to $2, so it's almost $4 off. That's usually what you think about. I know a lot of stores now have those scan things on the. Every so often you'll find one around. You can scan it. You check the price
on, but not all stores have those. And my luck, a lot of times they're not working when you go by or something like that, because that's the way it goes. Okay, so finding that percent off. Now, discount, you should be getting what kind of price from the original? Smaller or bigger?
Bigger. Smaller.
Smaller. If it's a discount, you're getting a smaller price. If you were doing a tax, taxes do what? Add to it. They make a bigger number. Okay, so your final answer should be a bigger price. Okay, taxes and tips are going to add, and then just finding that percentage is what you're doing. It's all percent problems. Setting up those proportions. You do the is over the of equals percent over 100. You're going to be okay, and finding those. There are shortcuts along the way, but the setup is key. If you don't set it up right, the shortcut doesn't show up. So this is what I want us to work on today. Tomorrow, we will work a little bit more on percentage, answering questions about these, and then we'll have a quiz tomorrow after lunch. Just one quiz tomorrow after lunch over percents. Tomorrow is Wednesday. I told you at the beginning we were changing up the process this week, doing a little bit differently. 7 day, 3-day weekend. You count the threes, it was 17 days. So, all right. So this is our assignment for today. Working on this. Go to this one down here, and